So I came across this problem of grade 11 physics problem. So a crane has an arm length of 20 meters inclined at 30 degrees with a vertical. It carries a container of mass of 2 tons suspended from the top end of the arm. Find the torque produced by the gravitational force on the container about the point where the arm is fixed to the crane. So the problem states to find the torque of here, force applied here. So let's rearrange or redraw the representation without the crane. So to redraw the problem without the crane, we'll use this representation. So as I said earlier, the inclination from the vertical to the arm length is negligible. So it isn't needed. So we can go straight away like this. So here's our axis. So the axis is where the point of the revolution occurs, or the rotation, I mean. And the gravitational force of the earth inclined at 150 degrees. Force and the position vector, or the arm length. Suppose that we have these values. We'll now follow the formula for the torque, which is torque is equal to position vector times force multiplied to the sine theta. So here in the given, we have the arm length of 20 meters multiplied by the force. So we don't have the force, but we do have the mass and the gravitational pull. So from the Newton's second law of motion, force is equal to mass times acceleration. We multiply the mass of 2 tons, so we convert 2 tons into kilograms. We have 2,000 kilograms multiplied to the acceleration of the earth, which is 9.8 meters per second squared. So we'll now have a force of 2,000 multiplied by 9.8 meters per second. So we have 19,600 newtons. So we input the force, which is the 19,600 newtons, then the sine. So the angle we'll use will not be 150 degrees. The angle used by the torque should be the reflexive angle, I mean the adjacent angle. So if we have the 150 degrees, we'll minus 180 with 150 to get 30 degrees. So torque uses acute angles only and doesn't cater it doesn't cater 91 and up angles or the obtuse and reflexive angle. So they only use acute angles. So we'll use sine 30 degrees. So let's use this. So what is sine 30 degrees? Sine 30 degrees is 0.5 or 1/2. So sine 30 is 0.5. Wait, write 0.5 here. Then multiplied to the force, 19,600 newtons, divided to the arm length, 20 meters. So we'll naturally have 20 multiplied by 19,600 divided by 2. So we'll have 196 1000 Nm. So the Nm here signifies for the multiplication of the arm length to the force in Newton multiplied to the meters. So that's how it is. Hope you like the video, guys. Leave a like if it helped. Subscribe for more videos. Thank you.